Okay, so I'd like to look at question number 2 of the 2015 paper 1. Once again, links in the description. And this is a sequence and series question. Most of the question 2s in matric papers are sequences and series questions. And if you'd like to have a look at my brief tutorial on sequences and series in general, before you do this question, it is there somewhere. I'll put a link in the description as well. Okay, so just to look at question number 2, if I can pull it up quickly. Question number 2 states the following geometric sequence is given. We've got 10, 5, 2.5, 1.25. So we can see immediately this is geometric. Obviously they tell us, but we can see it's geometric because it's got a common ratio. That common ratio is a fraction, and therefore this will converge. Okay, but let's actually go and work this all out. We can work through it as we go along. Okay, so let's write down the thing. So it says you've got 10, 5, 2.5, and 1.25. Okay, so question 2.1 asks to calculate the value of the fifth term T5. Now, obviously we can work that out. We might as well, because they're asking for it. Well, you have to, but you can do it the quick way because it's just 1, 2, 3, 4, fifth term. So we first got to work out the common ratio. The common ratio for this is simply 5 divided by 10, and that equals 2.5 divided by 5, and that equals clearly a half, or 0.5, however you want to write it. Okay, so now we have our common ratio, which is a half. We simply go and say, well, 1.25 times a half. You can divide it, but then you got to divide it by 2, because that divided by 2 is 5, that divided by 2 is 2.5. Or you can say, well, we've got a half as a common ratio, so we multiply by our common ratio. And you're always going to multiply by your common ratio or divide by the fraction. So we get 1.25 times 0.5, and 1.25 times 0.5 equals 0.625. Alright, so we get 0.625 as our fifth term. Now, the next question asks 2.2 says determine the nth term. Okay, Tn in terms of n. A lot of n's, but all that says is determine the general's formula of this. Tn equals what? Well, Tn we know is a r n minus 1. We know that because it's geometric. And this is quite simple in the sense that Tn is equal to a, which is the first term, 10, times by r, which is 0.5 to the power of n, which is just n, minus 1. We can simplify that if you want. I'm not going to bother. Okay. Then we look at the next question, 2.3. 2.3 says explain why the infinite series 10 plus 5 plus 2.5 plus 1.25 plus converges. So we've got this 10, 5, 2.5, maybe I should put semicolons, 1.25, etc. as our series, our sequence. And we make this a series by simply adding them together. Once again, if you're confused, just go have a look at my sequences and series video. Plus 2.5 plus 1.25. And we can see that this converges. In other words, it's going to converge to a point, to a number. And that number is going to be probably 19 by the looks of it, 5, 10, 15, 17 and a half, 18. So probably 19 or thereabouts, maybe a little bit more. But it's going to converge to a number. And how do we know that? It's asking us, why does it converge? Well, we know that a geometric sequence or series converges if r is less than 1 but greater than negative 1. In other words, if r is a positive or negative fraction, it will converge. So you answer this question by saying a geometric sequence sequence or series will converge if r is less than 1 but greater than -1. Okay, so that's your answer. And that's kind of the crux of it. The next question says determine the sum to infinity minus, just to elaborate on the previous one, r is a half. In this case, r is equal to 0.5, which is clearly a fraction. It's less than 1 but greater than -1, so it clearly fits the the condition. In 2.4 it says determine s. So let's just actually bring this up because we've got this here. So it says determine the sum to infinity minus some n in the form of a times b to the power of n, where Sn is the sum of the first n terms of the sequence. So it's quite a strange and weird sort of question. So what do we have to do? How do we even start that? Well, we start that by first writing it down, and we say, well, sum to infinity minus Sn, that's what they're asking. And they want it in the form of ab to the power of n, where Sn is the sum of the first n terms and S infinity is obviously the sum to infinity. So where do we even start? Well, I suggest you start by writing down the general formula. What is the general formula for sum to infinity? Well, it's a divided by 1 minus r, and the general formula for Sn is a 1 minus r to the power of n divided by 1 minus r. So they're saying write this in the form of ab to the power of n. Now that a is not necessarily the same as that a, so don't get confused. They're not the same. They just want it in the form of you have some number, for argument's sake. Let's go with 5, and then we have b, which is 0.8 to the power of n. They want it in this sort of form. Now how do we get that? Now I'm not saying that's the answer, it's certainly not the answer, but how do we get that? Well, we start by simplifying this. We can see that this over here and this over here are exactly the same, so we have a common denominator. That means that we can write this as a minus a 1 minus r to the power of n divided by 1 minus r. Okay, so we can expand this by saying, well, a minus a times 1 is just a minus a times that is plus a r n divided by 1 minus r, and that simplifies out nicely because the a's cancel to a r n divided by 1 minus r. And now that we have that, let me just write it again, a r n over 1 minus r, we can substitute our values for a and for r. We know that a is the first term, which is 10, and r is the ratio, which is a half, 0.5, or you can literally write it as a half, it makes no difference. Then we substitute those values in. So a is 10, r is 0.5 to the power of n, divide that by 1 minus 0.5, and 10 divided by this thing, which is a half, is 20, 0.5 to the power of n, and that is your final answer. Okay, and that's it. Simple as that.